So this is from day 13, a cool down called Majors and Salaries. What you're going to need to be doing is looking at a distribution based on the number, the salary, the amount of money certain people make based on their college major. What you're going to need to be able to do is look at the distributions and then look at the mean and a standard deviation and figure out which mean and standard deviation goes with which distribution. So, a couple things to keep in mind. The more variation a distribution has, the more spread out the data is, the bigger the variation is, the greater the standard deviation will be. The more compact distribution will have a lesser standard deviation. So if we look at these two graphs over here, these dots are closer together in general than these dots, and that shows up in the standard deviation. We have a smaller number for the standard deviation down here than we do up here. The mean is another good thing to look at, 3.87. That's right around here. This isn't perfectly symmetric, but it's close-ish to the middle. Here, mean of 7.73, that's like right around here. Again, this is not perfectly symmetric, but that's fairly close to the middle right there. Standard deviation is calculated using the mean, so it makes sense to use it as a measure of variability when the mean is appropriate to use. And in cases where the median is more appropriate measure of center, we're still going to use IQR than the mean. It's still a better choice than standard deviation. So, taking a look at this, the mean salary of 100 recent college graduates who majored in engineering was $63,750 with a deviation of 10,020. Look at the means, look at the averages. Those should be fairly close to any large peaks that you see on your graph or towards the middle of your graph. And then look at the variability. This one has the most variability. The standard deviation of 19,400, that's a whole lot more than the other ones. That one should be a whole lot more spread out in general. So take a look at each of the distributions, consider the numbers and what they mean for the distributions, and make your choices. If you're still not sure how to do this, let me know.